Hello class, this is the Elementary Statistics and Research. My name is James Quinn, and what I'm going to do today is I'm going to go over Chapter 1, and I'm going to make several small videos, and hopefully it'll give you a little bit better understanding about the different modules that we're going to go over throughout the course. So what I want to do, I want to start out with Chapter 1 today, and it's going to be the same PowerPoint that you have on D2L. So Chapter 1 basically is an introduction to statistics. We will talk about some of the things that you will be going to be studying throughout the course of the semester. And when my projector warms up here, we will get started. So here's the essentials that we need to look at, the logic of research and the purpose of statistical procedures, why we need to do these things, where you're going to find them in society, some of those things, a lot of sports use statistics, political polls, researchers, scientists, they all use research and statistical methods. Doctors who are developing new medicines, they have to go through a statistical hypothesis testing procedure to make sure that their medicine is actually proven for the effects it claims to have. Then how to recognize relationships between variables. Well, the variable such as height and weight, there is a strong relationship between height and weight because as one gets taller, usually one weighs more. So there is a strong relationship between those two variables. What the difference is between an experiment and a correlation. Well, when we're dealing with experiments, usually what we're trying to do is we're trying to find a cause for something to happen. And when we're looking at a cause, usually we're going to say, well, the outcome was caused by this intervention or this treatment that was introduced. Different types of variables like the independent variable and the dependent variable. Well, our independent variable is always going to be our treatment or the intervention that a scientist uses to determine the cause of the outcome, and the outcome is always going to be the dependent variable, something that you can actually measure. Since I'm a counseling instructor, I'm a licensed mental health therapist, I do a lot of counseling, so my research is going to be a lot of counseling based. So I may say that, well, for 8th grade boys who don't have a lot of self-confidence, I can say that through recreational therapy, 8th grade boys will increase their self-confidence. Well, I've got my independent and my dependent variable right there. My independent variable is going to be recreational therapy, and my dependent variable is going to be the increase of self-confidence. What are the 4 scales of measurement? Those things, we need to know about those because some of the scales we're only going to be dealing with nominal and ordinal level data, which are basically qualitative in nature, not quantitative. They're categorical data. And when we use interval and ratio scales, we're going to be dealing with means and standard deviations and things like that. So we have to have equal intervals between the numbers. So we can break things down into fractions. So we can use a higher mathematical scale, and we can differentiate between these scales by different characteristics of the data. Statistical procedures that we use, we want to be able to organize, and that's some of the things we're going to talk about soon, is organizing the data, being able to summarize the data, communicate the data. What does the data tell us about whatever it is that we want to be able to report on? And then we want to be able to interpret what the data is telling us. Well, we got logic of research. The goal of science is to understand the laws of nature. Well, some things occur naturally. They're a natural phenomena in the world, and we want to be able to understand what those laws are and pertaining to the behaviors of living organisms. It may be human beings, it may be animals, sea creatures, birds, whatever we are interested in, we may want to know more about that as educated people, so we want to be able to understand statistics and research. Samples and populations, this is something that we really need to understand before we can really appreciate how research is conducted. Well, we have the entire group to which a law of nature applies as a population. So if I say all 8th grade boys, that would be all 8th grade boys all over the world. Now, there's no way I can study or observe all 8th grade boys. So all I would need to do, I would need to pull a sample from that population, and that sample may be in Tulsa, it could be in Okmulgee, it could be anywhere. I can pull a sample of 8th grade boys and actually generalize my findings to the entire population. And there we go, a sample is a relatively small subset of a population intended to represent or stand for the population. So I can actually generalize to a population if I do adequate, I wouldn't say adequate, if I really have stringent sampling techniques. And we'll go into sampling later on in the semester. The individuals measured in a sample are called the participants. We used to call them subjects, but well, that's not politically correct, so we want to call them participants and not subjects. Obtaining data, a variable is anything when measured can produce 2 or more different values. Some common variables are age, race, gender, intelligence, personality type. Those are some types of variables. Relationship. Like I said before, a relationship is just something that we want to find that occurs in nature. Is there a relationship between hours of studying and grades? I would say that if you study more hours in the week, then your grade will be higher. So the more hours studying, the higher the grade. So there would be a relationship there. And the fewer hours that you study, the lower your grade would be. That may be, I haven't done that research, but that could be something that someone may want to look at some point. Okay, relationship consistency. If a score on one variable is paired with another, we see that we have a perfectly consistent relationship. So if height and weight, if someone were an inch taller and they gained 10 pounds per inch, and that was consistent over the height of every person and the weight of every person, you would have what's called a perfect positive correlation. We need to not have perfect consistency in order to have a relationship, because perfect relationships don't usually occur in nature. When the same set of y scores are paired with every x score, and basically y and x, that's what we're going to plot our relationship on, the variables, and usually our dependent variable is always going to be on our y-axis, and our independent variable is going to be on our x-axis. The y-axis is going to be the vertical axis, and the x-axis is going to be on our horizontal line. So, and we'll go over these things in more detail. I just want to give you a brief overview of what we're going to be doing this semester. Applying descriptive and inferential statistics. Well, when I say descriptive, I want the data to actually describe something, describe who my participants are. So I might want to look at age, race, socioeconomic status, religion, gender, a lot of those descriptors that would actually describe the population or describe the sample that I've researched. Well, inferential statistics, those are things that I'm going to make inferences on. So if I pull statistics down and I actually analyze the statistics, and I'm going to make an inference about a certain group of people based on the statistics that I have. Our procedures which organize and summarize sample data. Well, I'm going to organize it and then I'm going to report on it. It's going to tell me something about the data. Inferential are procedures for drawing inferences about the scores and relationship that would be found in a population. So I'm always going to generalize to the population even though I'm working with a sample. statistic is a number describing an aspect of the scores in a sample. A parameter, we're talking about the actual population. If I'm talking about parameter, I'm talking about the population, and usually the symbols are a little bit different. We're going to be using Greek letters when we're talking about parameters, and usually we're just going to be using regular Roman or English letters for a sample. And here we go. Parameters use Greek letters, statistics use English or Roman numerals. Understanding experiments and correlational studies, those are two different things, and we'll learn more about that, of course, as the semester progresses. A study's design is the way the study is laid out. So if you're going to develop a design, you're going to basically say who your participants are, who your population are, what statistical procedures you're using, what methods you're going to be using. You're going to have research questions. You're going to have independent and dependent variable. You're going to lay it all out so people will know. So when they read your research, they can actually replicate the research being done. There are two major designs that we have. One is an experiment and one is a correlation. When we're looking at a correlation, we're not looking for cause. We're just looking for a relationship. Is there a consistent relationship between two variables? Now, when we're looking at experiments, we're actually looking, does this intervention or this treatment that I've introduced to this sample, does that actually cause a change in this, population? So that's what we're doing here. In an experiment, the researcher actively changes or manipulates one variable, and that will be the independent variable, and then measures the participant's score on another variable, and that will be the dependent variable, to see if a relationship is produced. That's what we're looking for. Or we're going to be looking for, is there a cause? Did this make a cause to the dependent variable? The independent variable is changed or manipulated by the experimenter. So if I'm doing therapy, I can manipulate that therapy. I can do an hour of therapy or 50 minutes of therapy, once a week, twice a week, 3 times a week. I can manipulate that how I see fit. A condition is a specific amount of category of the independent variable, creating the specific situation under which participants are studied. So the condition is something that you're going to set up as a researcher as well. You're going to determine what the amount of the independent variable is, and basically you're going to be able to manipulate the condition as you see fit. The dependent variable is a variable measuring the behavior or attribute that you're trying to study. So that's what we're looking at here. When we're doing this research with the 8th grade boys and we're wanting to increase their self-esteem, self-esteem would actually be what we're going to be measuring. This will be influenced by the independent variable because I'm doing something to increase self-esteem. Correlational study, the researcher measures participant scores on 2 variables. And we're trying to find a consistent relationship between 2 variables. And we're going to see if there's a relationship actually present. Characteristics of scores. Measurement scales, nominal, ordinal. Let's take a look at these two. A nominal scale, we're looking at just categorical data. And a good example of that would be names or numbers. Well, if I had a football team, I'm going to assign numbers to different positions. There are different categories, like the tackles, the guards, the centers, the wide receivers, the quarterbacks, the running backs, the receivers, people like that. And usually I'm going to assign a specific number category to those different positions. So I'd be using what's called a nominal scale. So remember, the N in nominal stands for names and numbers. That's the only thing we can do. On the ordinal scale, what we're going to do with this one is we're going to assign rank order. So if I have a bunch of Coke cans, or not Coke cans, but different soda pop cans, and I drink each soda, and then I will rank order those sodas in the preference that I prefer. And if I have Dr. Pepper, I like Dr. Pepper. If I have root beer, I like root beer a little more than Dr. Pepper. Well, I've assigned a rank order to that. I'm still using categorical data because I can't, divide up my Coke cans into fractions. I'm still dealing with a category, and we're still looking at Dr. Pepper or Coca-Cola or root beer or whatever, but I will assign rank order to those Coke cans or soda cans based on my preference of taste. Another good indicator of this would be like categories of rank in the Army. You have a private, you have a corporal, you have a sergeant, lieutenants, majors. As the rank goes up, usually there is more responsibility and things like that. One actually has more order and rank than another does, and more importance. The interval scale. Well, interval scale, we can do a lot with the interval scale because we can start chopping up our data into actual fractions. We're not looking at categorical data anymore. We can actually use what's called continuous data, whereas in the ordinal and the nominal scales, we're only dealing with the discrete type of data, where we can't chop it up into fractions. Now we can start chopping these things up into fractions because with an interval scale, we can actually separate the categories, and we can basically break those categories up into fractions. But the fractions in each category have to be equal. So a good indicator of this, or an example of this, would be Fahrenheit temperature. Well, I've got an equal amount of temperature between 0 and 10 degrees as I have as 100 and 110. The amount of temperature is equal. It's the same. But we don't have what's called a true zero. We have what's called an arbitrary zero, because with the temperature can actually go below 0. So 0 really doesn't mean what it claims to mean. So I can have a temperature of minus 10 degrees below 0, but the increments of temperature are the same between minus 10 and plus 10. There's not an inequality of temperature. It's all going to be the same. Well, on my ratio scale, I'll have a true zero. I'll have what's called an absolute zero. There's a temperature scale called the Kelvin scale, and basically the Kelvin scale will allow us to go all the way to absolute zero, where there's actually no molecular activity occurring at 0 level Kelvin. And that would be a true 0 point. Another example of a true 0 point would be a ruler. It has a absolute 0. There's no negative inches. And we have equal intervals. We could have a scale of 1/4. We could have a scale of 1/8, 1/16, 1/32, 1/64. Basically, that means there's equal amounts between inches. There's 64 parts to an inch between 1 inch and 2 inches, but that same scale, 64 parts between 1 inch and 2 inches. So those things are going to be equal. And it will have a true 0 point, where interval scale will not have a true 0 point. It can actually go below 0. Continuous data and discrete data, I think I've kind of described what those are. Continuous data, or the continuous scale, we can actually chop the data up into fractions, where with discrete, it cannot be broken down into smaller parts. That's what I was talking about with sergeants and corporals. We're not going to chop those ranks down into smaller parts. They're going to be a whole. Or my pop cans that I prefer to drink, we're not going to chop those up into fractions. They're going to be wholes. So we can't make smaller amounts, but with a continuous scale, we can turn those into fractions. Example indicate, well, let's take a look at some of these. These are on your PowerPoints. The amount of tickets sold in an event, the flavor you prefer in soft drinks, okay, weight, IQ. So they're wanting to know what measurement scale this is on, and whether it's discrete or continuous data. So our next slide will reveal the answer for us. Well, it looks like with the number of tickets sold to an event, we have ratio because, we can't have negative tickets sold to an event. But we have discrete data because we can't chop those tickets down into smaller parts. The flavor of soft drinks that you prefer. Well, it's ordinal because we've ranked order. We've given them some rank. We prefer root beer over Dr. Pepper. So we've actually ranked those. And it's still discrete because I can't chop it into different parts. Weight. I can't weigh negative pounds. So I have an absolute zero there. So I have a ratio scale of measurement with continuous data because I can actually chop those levels of weight up into fractions. I could weigh 242.5 pounds. And IQ is our intelligence quotient, and that will be on an interval scale because we don't really know what zero level IQ is. So it doesn't have an absolute zero. And it is continuous because we can actually, break it down into fractions. And that's it for this section. Thank you.